This video is about calculating speed and velocity of an object moving in a straight line. After completing this assignment, you should be able to relate an object's speed to its distance traveled and the associated time interval, relate an object's average velocity to its displacement and the associated time interval, correctly use either velocity, which is a vector, or speed, which is a scalar, in a calculation, depending on the circumstances of the problem, and determine the instantaneous velocity of an object that moves with a varying speed. To get the most out of this video, you should have a solid understanding of the differences between scalar and vector quantities, how to calculate distance and displacement, and unit vectors and their notation, such as I hat, j hat, and k hat, which represent the x, y, and z directions. This ball moves 9 meters to the right in the positive x direction. If it takes 2 seconds for the ball to move 9 meters, you can determine the ball's speed by dividing the distance it traveled by the interval of time it took to travel that distance. Dividing 9 meters by a time interval of 2 seconds gives an average speed of 4.5 meters per second. But let's say the ball then moved 5 meters in the opposite direction and it took 1.5 seconds to do so. You can find the average speed of the entire trip in the same way. The speed is the total distance traveled, 9 meters plus 5 meters, divided by the total time interval, 2 seconds plus 1.5 seconds, which is equal to 4 meters per second. These measurements tell you about how fast an object moves, but nothing about the direction of the motion. Velocity, on the other hand, is a measurement of both how fast something moves and the direction of that motion. Let's consider the same ball moving 9 meters to the right in 2 seconds. To find this ball's velocity, divide the ball's displacement by the time interval of that displacement. The displacement, delta x, is a vector quantity, so it has both magnitude and direction. Here the ball's displacement is 9 meters in the positive x direction. You can divide that by 2 seconds, which is the time interval of that displacement, and you get an average velocity of 4.5 meters per second in the positive x direction. The ball then moves 4 meters in the negative x direction in 1.5 seconds. So let's include this motion to find the average velocity of the total trip. The total displacement is 9 meters minus 4 meters, which is 5 meters in the positive x direction, and the time interval of the total trip is 3.5 seconds. This gives an average velocity of 1.4 meters per second in the positive x direction for the total trip. You can also determine the average velocity for the total trip by using the total displacement, which is the vector delta x drawn from the initial position to the final position. The final position, 5 meters, minus the initial position, 0 meters, divided by the total time interval, 3.5 seconds, gives an average velocity of 1.4 meters per second in the positive x direction. This is the same answer you got previously when you separated the calculation into 2 parts, because both methods of calculating the average velocity are valid. Now that you know how to calculate speed and velocity, consider the following problem. A ball, initially at the 1 meter mark, moves 5 meters in the positive x direction in 2 seconds. It then moves 3 meters in the negative x direction in 1.5 seconds. Then it moves 7 meters in the positive x direction in 3 seconds. What are the average speed and average velocity of the ball over the entire trip?